In this video, we'll be taking a look at the most basic form of machine learning, which is linear regression. In linear regression, you train your model in order to find the line that best fit your data. And so to start off, we'll need to import the standard libraries. So import pandas, import numpy, we'll need matplotlib, and lastly we'll need TensorFlow. And so in this example, we'll be using a data set that maps the relationship between years of experience and salary. And so we'll take the first column and use that for our independent variable. And then we'll use the second column and use that for our dependent variable. And I'll just show you what it looks like really quickly. And so it kind of looks like this, where people with 4 years of experience tend to make roughly $60,000. And we'll remove that for now. Alright, now we're going to define our hyperparameters. And so epochs are the number of iterations, the number of times you end up computing the gradient. And then the learning rate is the magnitude of the gradient, so it's the number of steps you take at every iteration, or the size of the steps, I should say. And next, we'll need to define our TensorFlow variables. So because this is numbers, we'll be using float32. We'll do the same thing for y. And then we will start off by defining a random weight and random bias. And so we can use numpy to do that. Now, in linear regression, a model is simply the equation for a line. And so all we need to do is multiply w by x and add the bias. Remember how in machine learning we use w for weight instead of m, as you would in calculus. And now we need to define the cost function. And in this example, we'll be using the mean square error. And so this is the equation for the mean square error. And essentially what it's doing is it's calculating the difference between the data point, which is right here, and our predicted value along the line. And so it's this red arrow right here. And the reason why we square it is because otherwise an arrow pointing up and an arrow pointing down would end up canceling each other out because you're summing all the values, and we just take the average of that. And so the mean square error is going to be tf.reduce sum, and then we're going to take our data point, subtract our predicted value, square it, and then divide by the total number of data points. Now the next thing we need to do is define our optimizer, and in this example we'll be using gradient descent. And what an optimizer does is it essentially tries to optimize our cost function or minimize it. And so gradient descent optimizer, and we're going to pass in the step size, which is the learning rate, and then we're going to tell it to minimize our mean square error. Now we need to initialize our global variables, and so tf.global underscore variables initializer. Now that this is initialized, we can go ahead and use TensorFlow's high-level API to train our model. And so we need to create a session, and then we need to pass our initialized variables. All right, and so what we're saying is for every epoch, we want to run our optimizer, and we are going to pass it a dictionary, and here we're mapping our data to the placeholders right here. Next, what we're going to do is we're going to print out the mean square error, the weight, and the bias every 10 epochs. And so like so. And if we ran that, you can see that at the start, the sum of all the arrows, and then taking the average, you would get this value. And as we train our model, this value gets lower because our line is doing a better job at approximating our data, and so the line ends up being closer to the data points. And you can see here the weight, which is the slope to our line, is converging towards roughly 10,000, and the bias is increasing. Now, if we wanted to plot the line, we could do for the predicted value, we're going to multiply the weight and then add the bias. And then we always have to tell it to explicitly show. And if I run that again, you can see down here that we have a line that is roughly approximating our data points. And so if we were given someone with 6 years of experience, we would guess or predict that they're making roughly $80,000, which isn't too far off of this data point right here. And so if you have any questions, let me know in the comments, and thanks for watching.